Welcome to another deep dive. You know how this works. We pick a topic and we go in deep. And today we're going deep on Henry Cavendish.
Oh, a fascinating choice. A real enigma of science.
He is. We've got some excerpts from a book about him, focusing mainly on that experiment he did to weigh the Earth.
Ah, yes, the famous torsion balance experiment.
But the more we dig into Cavendish, the more I realize how little I knew. It's almost like a puzzle, you know? Like, how could someone who practically hid from other people manage to make such groundbreaking scientific discoveries?
It's a good question. That's the paradox of Cavendish, isn't it?
Sure.
Immense wealth, brilliant mind, yet he lived almost as a recluse.
Yeah. Okay, so let's back up a bit. Start at the beginning. Cavendish, he's born in 1731, aristocrat through and through.
Oh, yes, blue-blooded lineage.
Right. But his father, Lord Charles Cavendish, now he wasn't your typical nobleman.
Absolutely not. Lord Charles was a fellow of the Royal Society, deeply involved in scientific circles.
Exactly. And you could say he kind of groomed Henry for a life of science. I mean, taking him to Royal Society meetings, giving him access to the top scientific minds of the day. Not exactly your average childhood.
No, not at all.
Yeah.
And it's interesting, Lord Charles chose to send Henry to Hackney Academy instead of Eton. That was a very deliberate decision, I think. It suggests a preference for a more modern, science-focused education.
Fascinating. So not the typical path for an aristocrat.
No, quite unusual for their social class at the time.
And then it's off to Cambridge, Peterhouse College, to be exact.
Yes, following a well-trodden path for the intellectual elite.
Right, but here's the thing. Almost none of his classmates ended up pursuing science as a career. It really makes Cavendish stand out, even in that environment.
He was an outlier for sure, driven by a deep passion for scientific inquiry.
It seems like it was more than just an interest for him, almost a calling.
I think that's a good observation. Science wasn't merely a pastime for Cavendish, it was an inherent drive. But there's also the tragic element to consider. His brother, Frederick, suffered a terrible accident while at Cambridge, a fall that led to lasting brain damage.
Oh, right. That must have had a profound impact on Henry.
It's hard to say for certain, but it's certainly possible that witnessing such trauma contributed to his withdrawal from social life.
Makes you wonder how events like that shape a person, especially at such a formative age.
Absolutely. It's all part of the complex tapestry of his life.
Yeah. So we've got this backdrop of privilege, this early immersion in science, and then this a potential turning point with his brother's accident. Then in 1760, Cavendish follows in his father's footsteps and becomes a fellow of the Royal Society.
A prestigious position indeed.
And he didn't just join, he practically lived there, attended every meeting, served on all the committees. The Royal Society became his world, even if he wasn't exactly the life of the party.
Well, it highlights the role these institutions played, providing a space for brilliant minds like Cavendish to thrive, regardless of their, shall we say, personality quirks.
Yeah, no kidding. Speaking of quirks, have you heard that story about how people had to be practically coached on how to even talk to the guy?
Oh, absolutely. The anecdotes about Charles Blagden, Cavendish's friend, are legendary. Blagden would have to prepare people for any interaction with Cavendish. Speak as if to the air, he'd say. Avoid eye contact. And be prepared for him to just walk away mid-conversation.
It's almost comical in a way.
It is rather amusing. But it also underscores the very real challenges of social anxiety, even for someone with a mind as brilliant as Cavendish's.
Seriously, can you imagine trying to collaborate on a project with him? You start to ask him a question, so Henry, what are your thoughts on? And poof, he's gone. But joking aside, it does make you wonder, did his reclusiveness actually help his scientific work in some way? Maybe that intense focus, being away from distractions, allowed him to delve deeper into his research than others could.
It's an interesting thought. We place so much emphasis on collaboration in science today, but there's something to be said for that uninterrupted deep dive into research.
Right, no distractions, just pure focus.
Exactly. And Cavendish certainly had the means to isolate himself. His wealth shielded him from the pressures of needing patronage or teaching duties. He was free to pursue his scientific passions wherever they led him.
And lead they did. Let's talk about his work on what was then called factitious airs, or as we know them today, gases.
Ah, yes, a fascinating area of study. This is where we really see Cavendish's genius shine through.
Back then, people thought air was just a single element, right? One thing.
That was the prevailing understanding at the time.
But Cavendish, through his experiments, he helped blow that idea out of the water. Pun intended, as we'll get to later.
His meticulous experiments were truly groundbreaking. They paved the way for our modern understanding of the atmosphere. It's easy to forget how revolutionary it was to realize that The air we breathe isn't just one simple uniform thing, but a complex mixture of different gases.
It's like he was unlocking a secret code that was hidden in plain sight.
In a way, he was. His work laid the foundation for modern chemistry.
So let's talk about some of these factitious airs that Cavendish was working with. What was he doing with them?
Well, one of his most significant achievements was isolating and studying inflammable air.
Which we now know as hydrogen.
Precisely. Cavendish determined its density, explored its explosive properties, even observed how the volume of gas produced differed depending on the type of metal he used in his experiments. It was all incredibly detailed, groundbreaking work.
It's amazing to think about him in his lab, essentially playing with highly flammable gas.
It was a different time. Safety standards weren't quite what they are today.
It's a good thing his wealth allowed him to have a well-equipped laboratory.
It's quite possible that saved him from a few mishaps.
Seriously, imagine if he'd been working in some poorly ventilated shed.
Well, let's not dwell on what could have gone wrong. The important thing is, Cavendish made these crucial discoveries. Imagine being the first person to realize that this invisible air could actually explode. It must have been quite the revelation.
It's like he was taming a miniature dragon in a bottle.
A very apt analogy. And all of this was taking place within the context of the prevailing scientific theory of the time, phlogiston.
Phlogiston, right. That invisible substance they thought was released during combustion.
Exactly. The idea was that when something burned, it lost phlogiston. And even a mind like Cavendish's interpreted his findings through this lens.
It's fascinating how even brilliant minds can get things wrong.
It's a good reminder that science is an ongoing process. We're constantly building upon, refining, and sometimes even discarding previous knowledge.
So even geniuses make mistakes. But what's amazing is how Cavendish's work, even when based on an incorrect theory, still moved our understanding forward.
Precisely. It's like he was chipping away at the truth, even if he didn't always have the right tools. His meticulous measurements, his insistence on quantifying everything, that laid the groundwork for later scientists to come along and build upon his findings.
Okay, so hydrogen wasn't the only factitious air that caught his attention. What else was he working with?
Well, he also did extensive work with fixed air, which we now know as carbon dioxide.
Ah, carbon dioxide. Essential for life, but also a bit of a troublemaker when it comes to climate change.
A double-edged sword, indeed.
Mhm.
But back to Cavendish. He isolated carbon dioxide from various sources and even figured out how to collect it using mercury because it dissolves in water. A very clever workaround for the time.
Always innovating. But it's his attention to detail that really stands out. Cavendish was obsessed with precise measurements, with accounting for every possible source of error.
That meticulousness was his hallmark. It set a new standard for scientific rigor.
And thankfully, he kept incredibly detailed notes on all of his work. He may not have published much, but those notebooks were a treasure trove of insights, rediscovered later, filled with ideas that were decades ahead of their time.
A scientific time capsule just waiting to be opened.
Exactly. So we've got Cavendish the aristocrat, turned meticulous chemist, diligently blowing things up and isolating gases. But as they say, where there's smoke, there's water.
A perfect segue. That brings us to one of Cavendish's most accidental yet monumental discoveries. The composition of water.
Oh, this is where things get really interesting. Tell me everything.
Well, remember his fascination with inflammable air and phlogiston? He was conducting experiments, sparking hydrogen and oxygen together.
Just a typical day in the lab, right? Creating miniature explosions.
It does sound a bit like that, doesn't it? But during these experiments, he noticed something peculiar. When he sparked the gases, they produced water. And not just water, but also an acidic residue.
Hold on. He's creating water out of thin air. That's some serious alchemy.
It was a game changer. But here's where his scientific rigor really shines. He wasn't content with just observing this reaction. He wanted to understand it completely. So he meticulously eliminated any potential sources of contamination, varied the proportions of the gases, really got to the heart of what was happening.
Always methodical, never jumping to conclusions.
Precisely. And through this quantitative approach, he managed to calculate the combining volumes of hydrogen and oxygen needed to produce water. And get this, his ratio was incredibly accurate, especially given the tools available at the time.
So this wasn't just a lucky accident. It was a carefully analyzed breakthrough.
Absolutely. And a monumental one at that. Before this, water was considered an element. Cavendish showed that it was actually a compound made from two other elements.
That's a complete paradigm shift.
A fundamental change in our understanding of a substance that's essential for life. And it all stemmed from this meticulous, inquisitive mind working away in his private lab. Quite remarkable, isn't it?
Absolutely remarkable.
Remarkable indeed, but it's funny, discovering the composition of water, it was almost a side project for him.
Really?
He was so focused on phlogiston, you see.
Ah, right. Phlogiston.
So his work with water, it was almost like, well, a happy accident.
A fortunate detour on his path to scientific enlightenment.
Exactly. But before we get too carried away with his chemistry exploits, let's remember Cavendish wasn't just a chemist. This guy, he was a true polymath, interested in all sorts of things.
Well, yeah, we were talking about his weather obsession earlier.
Oh, a dedicated meteorologist, that's what he was. Meticulously recording weather data, calibrating his instruments, taking precise measurements. He even suggested that the Royal Society should publish regular weather observations.
Really? Wow.
Oh, he was fascinated by it all. The patterns of the natural world, not just what he could create in his lab.
That's so cool. It's like he saw the Earth itself as one giant experiment.
That's a great way to put it. And that meticulousness, that need for precision, it was a driving force in everything he did.
Absolutely. You see it in all his work, whether he was tracking storms or sparking gases, there was always that same attention to detail.
Always. And speaking of sparks, did you know Cavendish also dabbled in electricity?
Oh, right. I'd forgotten about that.
And this is where things get really interesting. He conducted a lot of experiments with electricity, and he nearly discovered Coulomb's law.
Coulomb's law, the one about the forces between charged particles.
The very same. But here's the kicker. He nearly discovered it a full 14 years before Coulomb.
Whoa, wait. So he was on the verge of another major breakthrough, but it just slipped away.
It seems so. His notes reveal that he had a very good understanding of electrical forces. He was really close to quantifying that relationship between charge and distance.
It's like he was right there on the edge of it.
He was. But, as was so often the case with Cavendish, he didn't publish his findings.
Classic Cavendish.
Those insights, they just stayed hidden in his notebooks. A testament to his brilliance, but also, a bit of a what if for the history of science.
It's almost tragic, to think of all that knowledge locked away.
It does make you wonder how much further ahead we might be if he had shared his work more openly.
Right. Okay, so we've got electricity, we've got weather. Anything else pique his scientific curiosity?
Well, he also delved into the nature of heat, which was a big debate in the scientific community at the time.
Yeah, heat. What even is heat?
The prevailing theory back then was that heat was a substance called caloric.
Caloric. Okay, another one of those invisible substances like phlogiston.
Exactly. They used it to explain things they couldn't see or fully understand.
Makes sense, I guess.
But Cavendish, being the independent thinker that he wasn't so convinced.
Oh, so what did he think heat was?
He favored a mechanical theory of heat. He believed that heat was actually the result of the motion of particles, not some mysterious fluid.
So instead of imagining some invisible stuff, he thought it was all about movement, about things bumping into each other.
That was his idea. And he was way ahead of his time on this one. His insights foreshadowed some of the key concepts that would later form the basis of thermodynamics.
Thermodynamics. That's getting into some pretty complex stuff.
It is. But Cavendish was already exploring those ideas. He even designed experiments to test his theory.
Always the experimentalist. So he's challenging the accepted wisdom again. It seems like he never shied away from questioning the status quo.
Not at all. It's what made him such a brilliant scientist. Always pushing the boundaries. Always searching for a deeper understanding.
What do you think it was about Cavendish that made him so willing to challenge dogma?
It's hard to say for sure. Maybe it was his isolation, his detachment from the mainstream scientific community, or perhaps it was his wealth. He didn't have to worry about losing funding or patronage if his ideas were controversial. He was free to follow his curiosity wherever it led him.
It's probably a combination of factors, right? His personality, his circumstances, his pure intellectual drive.
I think you're right. It was a unique confluence of elements that created the perfect environment for Cavendish's genius to flourish.
Makes you wonder if those same conditions could be replicated today, to foster that kind of independent, groundbreaking thinking.
That's a fascinating question. Perhaps we can learn something from Cavendish's story about how to create spaces where unconventional ideas can thrive.
Food for thought, for sure. But all of these threads we've been talking about, his meticulousness, his willingness to challenge dogma, his insatiable curiosity, they all come together in his most famous experiment, The one that earned him the title of the man who weighed the world.
Ah, yes, the torsion balance experiment,
Mhm.
the pinnacle of Cavendish's scientific achievements.
So tell me, how did he actually do it? How do you even begin to weigh something as massive as the Earth? It seems impossible.
It all started with a gift from his friend, Reverend John Mitchell. Another brilliant mind, by the way.
A friend? I thought Cavendish didn't have many friends.
Blagden and Mitchell were the exceptions, it seems. They shared a deep passion for science.
That's so cool. What was this gift?
Michel had designed this ingenious instrument called a torsion balance, specifically for measuring the Earth's density. Sadly, he passed away before he could conduct the experiment himself.
Oh, that's sad.
But he left his apparatus to Cavendish, knowing that he was the only one with the patience and precision to pull it off.
What a gesture.
Yeah.
Passing the scientific torch, so to speak. Okay, so what exactly is a torsion balance? Is it like one of those old-fashioned scales you see in antique shops?
Not quite. A torsion balance is incredibly sensitive. It works by measuring the tiny twisting force created by the gravitational attraction between objects. Picture this: a very fine thread suspending a rod, with small weights on either end. Even the slightest gravitational pull will cause that rod to twist.
Okay, I'm trying to picture it. So how does that tell you how much the Earth weighs?
By measuring the angle of that twist, you can calculate the force involved.
Right. But how do you go from a tiny twisting rod to the weight of the entire planet?
Ah, that's the brilliance of Mitchell's design and Cavendish's execution. Mitchell's concept was brilliant, but Cavendish, he took it to the next level, you see. Made a number of modifications and refinements to ensure absolute precision. He even enclosed the whole apparatus in a separate room to minimize any disturbances.
He was serious about this, wasn't he?
Oh, absolutely. And he observed the tiny movements of the rod through a telescope mounted in the wall, so he wouldn't even have to enter the room and risk affecting the results.
Social distancing to the extreme.
Right. But it makes sense. He knew that even the slightest draft or change in temperature could throw off his measurements. He had to control every possible variable.
Talk about meticulous. Okay, so what did this meticulously crafted experiment actually look like? Paint me a picture.
All right, so imagine a wooden box, very carefully constructed, shielding the experiment from any outside interference. Inside, there's a 6-foot-long wooden rod suspended horizontally by this very thin wire. On each end of the rod are these small lead balls.
Lead balls.
Got it. And then the stars of the show. 2 massive lead spheres, each one weighing over 350 pounds.
Whoa, so we've got a tiny rod with tiny lead balls.
Yeah.
And then these giant lead balls lurking nearby.
Exactly. And those big spheres, they were carefully positioned near the small lead balls on the rod.
Okay, I'm picturing it.
Now, because of gravity, those large spheres, they exert a tiny but measurable pull on the smaller ones, causing the rod to twist ever so slightly.
Ah, I see. So it's that teeny tiny twist that we're measuring.
Precisely. And that's where the incredible sensitivity of the torsion balance comes in.
Okay, so we're measuring the twist caused by the gravitational attraction between the lead balls, and then how do we get to the weight of the Earth?
By carefully measuring the amount of twist and knowing the masses of the lead balls and the distance between them, Cavendish could calculate the gravitational force between them.
Right, and once he knew that, he can then...
Extrapolated to the scale of the Earth. That's the mind-blowing part.
Whoa. Hold on. He's taking information from these tiny twisting lead balls in his lab and using it to figure out...
The weight of the entire planet.
That's insane.
It is pretty incredible. And there's more. Remember, Newton's law of universal gravitation. It states that every object in the universe attracts every other object.
Yeah, vaguely. It's been a while since high school physics.
Well, Cavendish, through his experiment, was able to determine the value of the gravitational constant. It's a fundamental constant in that equation.
Wait, so he's figuring out a key piece of how gravity works throughout the entire universe just by observing these lead balls in his lab?
Exactly. His experiment wasn't just about determining the density of the Earth, which he did with incredible accuracy. It also provided a numerical value for the gravitational constant, something that had eluded scientists for over a century.
Mind officially blown. This is amazing. He's weighing the world, figuring out the secrets of gravity, and he's doing all of this at home.
It's a testament to his genius, his persistence, and his unwavering belief in the power of careful observation.
Okay, but how do we know he got it right? I mean, we can't exactly put the Earth on a giant scale and check his work.
That's a good point, and it gets to the heart of the scientific method. We can't weigh the Earth directly, that's true. But we can repeat experiments, see if the results hold up.
And
Over the years, scientists have repeated Cavendish's measurements, using increasingly sophisticated equipment, And guess what?
What?
They've consistently confirmed his findings. There are slight variations, of course, due to improvements in measurement techniques, but the fundamental results have held true.
That's incredible. So Cavendish's legacy isn't just about his specific discoveries, it's also about the enduring validity of his methods.
Precisely. His work paved the way for future generations of scientists to continue exploring the mysteries of gravity and the universe. He gave us a tool, a way of understanding the invisible forces that shape our world.
And he did it all while avoiding human contact as much as possible.
Right. It makes you wonder how he reconciled those two sides of himself, the brilliant scientist and the reclusive, almost antisocial personality. Was there a connection between the two? Did his isolation fuel his scientific drive?
That's a fascinating question. It's almost like his scientific pursuits were his way of connecting with the world, even as he physically distanced himself from it.
Maybe his experiments, those meticulous observations, were his way of making sense of a world that often felt chaotic and overwhelming.
And that meticulousness, that obsession with precision, it wasn't just about getting the right answer. It was about understanding the universe at its most fundamental level.
Yes, it was about searching for a deeper truth, hidden beneath the surface of things.
Beautifully put. And that search for truth, that relentless curiosity, that's what defines Henry Cavendish, not just as a scientist, but as a human being.
Absolutely. He may have been an enigma, but he was an enigma who left an indelible mark on the world.
We're back and ready to wrap up our deep dive into the life of Henry Cavendish. What a journey, right? From weighing the Earth to isolating gases, it's been a wild ride through the mind of a scientific genius who was, well, let's just say, a bit of an oddball.
He was certainly a man of contradictions. Brilliant, but reclusive. Wealthy, but indifferent to money. He made discoveries that revolutionized science, but he barely published any of it. It's almost like he was content to let his notebooks speak for themselves.
It's almost like he did science for the pure joy of discovery, not for fame or recognition.
It does seem that way, doesn't it?
Yeah.
But let's talk about those eccentricities a bit more. We've touched on his shyness, his aversion to conversation. But what else can you tell me about this side of him?
Yeah, give me the good stuff.
Well, his solitude went beyond just being introverted. Cavendish lived alone in his London home. It was more like a private laboratory and library than a place of residence. He even had a separate staircase built, just to avoid running into his servants.
Seriously, a separate staircase, just to avoid people.
That's the story. Can you imagine going to such lengths to stay out of everyone's way?
I guess when you're that brilliant, you can get away with being a little eccentric.
Maybe so.
Hmm.
But amidst all this isolation, he did have at least one close friend. We've mentioned Charles Blagden a few times.
Yeah, Blagden, the guy who had to coach people on how to talk to Cavendish.
Right. Blagden was a fellow scientist, a regular visitor to Cavendish's home. He seemed to be one of the few people who could tolerate Cavendish's quirks.
Sounds like they had a special bond.
They did. They collaborated on experiments, shared their passion for scientific inquiry. Blagden was really the link between Cavendish and the rest of the world.
A scientific translator of sorts?
That's a great way to put it. So, apart from revolutionizing science and avoiding people, what did Cavendish actually do with his time?
Yeah, did he have any hobbies? Or was it just science, science, science?
Believe it or not, he was quite the collector. Books, minerals, you name it.
Really? That's surprising.
His library was enormous, covered all sorts of scientific topics, and his mineral collection was very impressive. Many of the specimens were sent to him by Blagden from his travels.
So even though he was a recluse, he still had a thirst for knowledge and a connection to the wider world.
Absolutely. He found ways to engage with the world on his own terms.
I like that, finding your own path. What about his personal life, though? Was there ever any romance, any family?
As far as we know, Cavendish never married and had no children.
Not surprising, I guess, given his personality.
Probably not. It seems his one true love was science.
A life dedicated to unraveling the mysteries of the universe. Not a bad legacy to leave behind.
Not bad at all. And speaking of legacies, Cavendish died in 1810 at the ripe old age of 78.
78. Not bad for the 18th century.
No, not bad at all. Even in his final moments, his eccentricity was on full display.
Oh, tell me more.
Well, the story goes that when his doctor arrived, Cavendish scolded him, saying something like, "I'm dying, there's no point in prolonging this." Can you imagine?
Always the pragmatist. Even facing death, he was concerned with control, with maintaining his privacy.
It's fitting, in a way, isn't it? A final act of defiance against the intrusions of the world.
It is. So, after spending all this time with Henry Cavendish, what's your takeaway? What can we learn from this brilliant, enigmatic figure?
It's made me realize that brilliance takes many forms. It doesn't always fit neatly into our expectations. Cavendish may have shunned the spotlight, but his impact on science was profound.
It's true. He really did change the world, even though he seemed to want nothing to do with it.
His story reminds us that sometimes the greatest discoveries come from the most unexpected places, and that sometimes the people who change the world the most are the ones who seek it the least.
That's a great point. So, listeners, we hope this deep dive into the life of Henry Cavendish has sparked your curiosity and maybe even challenged your perceptions of what it means to be a scientific genius. Thanks for joining us on this journey.